And little by little, that's how you eat an elephant. For the given ellipses, so they're telling you they're ellipses. That's awfully kind. So we go to our little formula sheet and we can see a big hint, equals 1, and here's our little formula. So we've got everything we need right here. And so we know that it has to equal 1, so we divide by 144. So we get x squared over 16 plus y squared over 9 equals 1. Now this particular one happens to have center 0, 0. It makes life nice. Take the square root of that, it's 4, because that's a squared. So if a squared is 16, a has to be 4, which is the distance we travel along the x-axis, because it's underneath the x value. And then we do the same thing here. B squared equals 9, so b equals 3. We go up and down 3. So there's our drawing somewhat, and now we can answer a bunch of questions. Where's the center? Well, the center would be 0, 0. Coordinates of the vertices, that happens to be the end of the major axis, so that's vertices would be plus or minus 4, 0. And let me make sure they don't want the co-vertices. Okay, so they're not asking for the co-vertices. So all they want now is the foci. The foci are on the major axis somewhere, and that's where the formula a squared minus b squared equals c squared comes from. A is always bigger than b for ellipses. Keep that in mind. So we know a squared is 16 minus b squared is 9. So we get 7 equals c squared, so we take the square root. So we know it's going to move left, square root of 7, right, square root of 7. Square root of 9 is 3, square root of 4 is 2, so it's in between there. But all they want is for you to label it, so the foci for this one would be plus or minus the square root of 7, comma 0. And then you're done. This one's going to be a little more involved, letter B. So remember it equals 1, but we got to get our constant over to the other side for starters. I'm also going to collect my x's, and I can see in order to complete the square I'm going to have to take a 12 out. I'm going to do the same thing with my y's, so I get 5y squared plus 30y, so I take a 5 out. I'm left with y squared plus 6y plus space equals 3 plus space, running out of space. So, take half and square it, that's a 12, so I got to add a 12 over here. Take half and square it. That's a 9, but that's 9 times 5, which is 45. Clean this up. Clean this one up. Add these together. So 15 and this is 60. And these should be made to work out. Remember, it equals 1. So we've got to divide everything by 60. And I'm going to use this space up here. So x minus 1 squared over 5. Plus y plus 3 squared over 12 equals 1. Now these numbers are a little wonky. So we take a look, and we know the center is going to be right 1 and then down 3. 1, 2, 3. I like to draw another xy axis, kind of like I call them crosshairs. And here we go. This has to be our a squared because it's bigger. This has to be our b squared because it's smaller. So a is the square root of 12 by taking the square root of both sides, which is, I mean, if you wanted to keep that, we'll just keep it. You could make it 2 square root of 3. I don't know if they're going to worry about that too much with this section, but I need to travel along my y-axis that far. So it's not necessary to have a nice, neat little drawing, but the square root of 9 is 3, square root of 16 is 4. This is 2 times 1.7-ish, so that's like 3.4, which makes sense in between there. So I'm going to go up 3.4. I'm going to go down 3.4, 3.4-ish. And then I'm going to take the square root of b, which is the square root of 5, which is like 2.2-ish. And so that would be 2.2, 1, 2, and a little smidge, 1, 2, and a little smidge. So at least I have a little bit of an accurate drawing to kind of go by for my brain to process information. So what's the center? The center is 1, -3. What are the vertices? Well, from there, I would go up the square root of 12 and down the square root of 12. So how do I take my center and adjust that? Well, that would be 1, -3 plus or minus the square root of 12. Or -3 plus or minus 2 square root of 3. But I don't think they're going to break it down, but you never know. And then what's the coordinates of the foci? Well, I got to use the formula. A squared minus b squared equals c squared. So that's the big one, 12 minus 5, which is 7. So I get 7 equals c squared. Looks like they're using the same distance to find our foci, but in this case, I have to go from the center up and down the square root of 7. So the foci, this is just a mess, would be 1 and then -3 plus or minus the square root of 7. And there you have it. Okay, next problem, number 20. Really feel like there's not enough room in here for this amount of information. So there's the drawing. Find the equation of an ellipse with vertices 3, 7 there, 3, -3 there. Foci, remember that's a clue. That means they're on our major axis, which means this is our major axis. So that means it's going to be y squared over a squared. Just keep that in mind. But the first thing we should do is find the center, which is going to be the center, the midpoint of these two, or the midpoint of these two. Don't care how you look at it. No matter how you dice it up, the center is going to be 3, 2. Now that's going to help us, because here's my x adjustment, here's my y adjustment. So I know it's going to be x minus 3 squared over, we'll talk about that in a minute, plus y minus 2 squared. And we know this equals 1, they just do. So I already gave you a clue. Because the foci are on the y-axis, we know this is the major axis, so therefore a squared is going to go here. Well, we can calculate a by going from the center to one of the vertices. So from 2 to 7 is 5. That's a. So we're going to square that, and we're going to get 25. Now the other clue they gave us is the letter C is the distance from the center to one of the foci. So that'd be 2 this way, 2 that way. So C is 2. So we're going to use this formula that they give us to find b squared, because that's what we need to put right here. So a squared, we already know is 25. B squared, because C is 2, we're going to square that, we're going to get 4. Subtract 25, subtract 25, we get negative b squared equals negative 21. Multiply both sides by negative. Now you're going to be tempted to take the square root, but don't. We want b squared. So you're tempted to do it, but b squared equals 21. And that's what we're going to put right there. And there you go. Number 21, find the equation of an ellipse. With foci 1, 5, there's one of them. 7, 5, there's the other one. We know the foci always are on the major. So we know right now that this is going to be the major is going to be, it's going to be x squared over a squared. So we also know that we can find the center of this ellipse by finding the midpoint of these 2 points. Well, from 1 to 7 is 6. Take half of it, it's 3. So that would be, the center of it would be 4, 5. So already from the center, we know part of our answer. is going to be x minus 4 squared, again, over a squared, tells me what I need to find, and then y minus 5 squared over b squared equals 1. Now let's read the rest for some clues. The entire minor axis is 4. That means I'd go up 2 here, down 2 here if I was going to draw the drawing, so it's going to look something like this. Not sure, but I do know that this is 2, half of the entire major axis. So b is 2, and I square it and I put it right here. So it's y minus 5 squared over 4. I know that much. Now we got to find a squared. How are we going to do that? Well, back to this formula, because we do have enough information. We know what b squared is. It's 4. So we're going to go minus 4. C, remember we said, is the distance from the center to the foci, so that's 3. So that would be 3 squared, which is 9, and that's a squared. So if we added 4 to both sides, we get 13. You tempted to take the square root? Don't. That's just going to be extra work. X minus 4 squared over 13, and there she is. On to hyperbolas, number 22. Hyperbolas, if you look at your little cheat sheet, there's a big clue there. Hyperbolas are also supposed to be equal to 1. That's a helpful hint. So we know what to do to get started. We're going to divide this all by 100, and then divide that by 100. And so we get y squared over 25 minus x squared over 4, because this reduces to 1/4, equals 1. I'm going to use this little piece of paper right here. Not enough space. So we know that our center is going to be 0, 0. We know that this is our a squared, not because it's bigger, but because it's first. See, a can be bigger than b. A can be smaller than b. A could even equal b in the world of hyperbolas. Different than ellipses, you know, so we have to be careful with that. It's just first or positive, not the negative stuff. So that means a is 5. And that means this is b squared. So that means b is 2. Plus or minus, if you want to get technical, which actually works here, because I need to go from the center up 5, 1, 2, 3, 4, 5, down 5, 1, 2, 3, 4, 5. I need to go along my x-axis too, and this time, because it's not an ellipse, I need a box, because that box is where I'm going to get my asymptotes from. There we go. Now how do we go from here to figuring out what our hyperbola looks like? Well, because it starts with a y squared, it's going to, that means my hyperbolas are going to engulf my y-axis. So that means this is my vertex and that's my vertex, and we have to go near our asymptotes, like so. But what does it ask us to find? Find the center. Well, that's pretty easy for this one. That's just 0, 0. Find the slope of the asymptotes. Well, that's going to be up. So if we start here, 1, 2, 3, 4, 5 over 2. So that's going to be positive 5 halves. This one will be up 5 left 2, so that's negative 5 halves. So we say the slope is plus or minus 5 halves. And then the coordinates of the vertices, like I said, are right here. So the vertices are 0 plus or minus 5. That's 0, negative 5. That's 0, positive 5. And then the coordinates of the foci. The foci are going to be up here and up here. That's what the hyperbolas engulf. So we're going to use the formula a squared plus b squared equals c squared. Don't get this messed up with the ellipsis formula. So we know a squared is 25. We know b squared is 4. So that's 25 plus 4, which is 29, equals c squared. So So we take the square root of that. So we need to go up the square root of 29, down the square root of 29. So our foci would be at 0 plus or minus the square root of 29. Good for that one. All right, going over the 15 minutes a little bit, but that's okay. Let's finish up this final hyperbola. So I've already taken steps. I've taken this 412 over by adding it. I've collected my x stuff and my y stuff, and now I'm preparing for completing the square. Notice I've taken the negative 16 out of here and a negative 16 out of here. That's why I have a positive and a positive. So we take half of this and square it, 4. And we got to add that to that side. Take half of that, it's 25. Squared is 25. But 25 times 4 is 100. 4 times would be 400. But that's minus 400. So, because that's a negative times a positive. So we got to do the same thing over here. Now let's clean this up. X plus 2 squared minus 16 times y plus 5 squared equals, all of this minus this is just 16. Now remember, this needs to be a 1. So I'm going to divide that all by 16. Clean this up. X plus 2 squared over 16. This reduces to 1 minus y plus 5. We need something underneath there, so we're going to put the 1 there, equals 1. Now, the problem wants us to find a bunch of stuff, so let me graph this really quickly. All right, so before we start figuring out what all these things are, we better get a picture. So I've identified the center, left 2, down 5, left 2, down 5. I know this is my a squared. Again, not because it's bigger this time, it just happens to be bigger because it's first. So I got to travel 4 units in the x direction. So this is 2, and then I need to go 3, 4. This is not very to scale, but 4 this way as well. 1, 2, 3, 4. This point is negative 2, negative 5, which will be very significant because everything kind of hangs on that. And then we're going to go the square root. This is b squared. So b is 1. So I need to go up 1 from there, down 1 from there, draw my box in. This could get messy. I'm sorry for that. And here we go. Draw in these asymptotes. Now, because it starts with x squared, or that's my positive stuff, that makes this a vertice, and that makes this a vertice, and my hyperbolas go that way. And we can, everything kind of hangs on that now. So the question is asking, find the center. We did, negative 2, negative 5. Slope. Well, that's 1 over 4 and 1 over negative 4. So the slope of this one would be plus or minus 1/4. Now the coordinates of the vertices, like I said, it's 4 to the right here, so that'd be 2, negative 5. 4 to the left of this, so that'd be negative 6, negative 5. There's our vertices. And the final thing is the foci. A squared plus b squared equals c squared. We know our a squared is 16. We know our b squared is 1. So 16 and 1 is 17. Take the square root. That means I need to move left the square root of 17 and right. So this is my center. So that's my x value. To go left and right, it needs to be negative 2 plus or minus the square root of 17, comma, negative 5. And that would be in here somewhere and in there somewhere. That does it for this recording.